Objects are symmetrical when both sides are exactly the same, when they're mirror images of each other. So I have a quadrilateral here. More specifically, it is a rectangle because there are 4 90-degree angles, 4 right angles in this rectangle. And the rectangle has 2 lines of symmetry. It has a vertical line of symmetry, and I'm going to prove to you that that is a line of symmetry there. So if I take this and I fold this figure this way, this side's going to match right up with that side. This angle or vertex is going to match up right with that angle or vertex. And I can put a mirror on the line and show you that it will look exactly the same. So when I put my mirror right on the line of symmetry and show you what that angle looks like, and when I pull my mirror away, that should look exactly the same as what it does now. So it's still exactly the same. So that is the opposite side of this one, is the mirror image of this side. So when I remove the mirror, it looks exactly the same because those pieces are symmetrical. All right, and we also have a horizontal line of symmetry. It goes right across horizontally on the object. And I need to, when I do this, I'm a little bit high there. I want to make sure that I'm right in the center of this. So right through the center of this figure for my line of symmetry. Because if I'm right exactly in the center, this bottom half is going to match up perfectly with the top half when I fold it. So showing that this is a line of symmetry as well. Put my mirror on there. And you can see that the top half in the mirror is exactly the same as the bottom, so it is a mirror image of the bottom, and when I remove it, it still looks exactly the same. So that bottom side is symmetrical to the top side. So we have a vertical line of symmetry and a horizontal line of symmetry. Now, some people like to say that you can take and put a diagonal line of symmetry into a rectangle. That is not true. If I were to fold this, this point here would end up way up here, and it wouldn't match up perfectly with that corner there. So to show that, I put my mirror down here and turn it a little bit more. That's good. Put my mirror down here and rotate it, and you can see that the mirror image of the bottom of this rectangle looks like that. When I remove it, it looks completely different. So this would fold up to the image that I'm seeing. So that is not symmetrical at all. So when I remove that, it's completely different. So a rectangle is not symmetrical on the diagonal. And this diagonal would be exactly the same. That would not be symmetrical either. So I have a vertical line of symmetry and a horizontal line of symmetry. Now, if I have a square, my vertical line of symmetry will work. And my horizontal line of symmetry will also work because if you notice, when I rotate that square, it's still exactly the same. I have because all my sides are the same length. So all those lines of the vertical and horizontal line of symmetry work. Now with a square, this diagonal line is also going to work as a line of symmetry. So from here through and also from there through, those will work as lines of symmetry. So when I put my mirror on here and I show you the image, you see that top half is exactly the same as that bottom half. When I remove it, that's how it looks. It looks the same. So the top is a reflection of the bottom. The bottom is a reflection of the top. The two sides are mirror images of one another. So a square has 4 lines of symmetry. And any polygon that has all the sides the same length will have that many lines of symmetry. A triangle that's an equilateral triangle, meaning all the sides are the same length, has 3 lines of symmetry. A square and a rhombus have all sides that are the same length. They have 4 lines of symmetry. A pentagon that has all sides the same length will have 5 lines of symmetry. A hexagon that has all sides the same length will have 6 lines of symmetry. A decagon that has all sides the same length will have 10 lines of symmetry. But all the sides have to be the same length for it to have that many lines of symmetry. Now here I have a parallelogram because opposite sides are parallel. It has 2 sets of parallel lines. And a lot of people think that you can fold parallelograms and make them symmetrical, but you cannot. If I put my vertical line of symmetry in there, watch what happens when I check this out. So in my mirror, the image that I see in the top should be exactly the same as what I see up there already. But when I look at this, I see in the mirror, I see a trapezoid right now. When I remove the mirror, I'm back to my parallelogram. So I put my mirror on there and I have a trapezoid. When I remove it, I have parallelogram. So those are not mirror images of themselves. Same thing with my horizontal line of symmetry. If I put that on there and I go down, look at that shape that I have. It's kind of like an arrow. And when I remove that, that's how it goes. So they're not the same. So my horizontal line of symmetry does not work for that. Same thing with my diagonal lines. So my horizontal line does not work either. And if I do it diagonally, watch what happens here. So when I remove the mirror, it should look the same as it does when I have the mirror down. So there's my parallelogram. And I put the mirror down, and look at that. When I remove it, it looks nothing like it. So though that is not a line of symmetry, those are not symmetrical. And the same holds true if I'm going the other way with my diagonal line. So I put my other diagonal line down, and the top is not the same as the bottom at all. The lines of symmetry do not match up. So despite what people think, parallelograms do not have any lines of symmetry unless all the sides are the same length. When all the sides are the same length, we have a rhombus or a square, and both of those will have 4 lines of symmetry, vertically, horizontally, and 2 diagonal lines of symmetry. So parallelograms have no lines of symmetry. Then I have a circle that has an infinite number of lines of symmetry because I can certainly fold this circle right in half. And it is still the circle. So the top and the bottom match up perfectly. And so if I make a line of symmetry right down and I rotate it, and I make another line of symmetry, and I rotate it, and I make another line of symmetry, I can do this as many times as I want. So a circle is infinitely symmetrical. I can put an infinite number of lines of symmetry in.